To my next class on quantum mechanics. Today I am going to explain about a principle put forward by Werner Heisenberg in 1927, that is Heisenberg's uncertainty principle. The statement of Heisenberg's uncertainty principle is that the product of uncertainties of any two conjugate quantities is greater than or equal to h cut by 2. That is, if we are measuring two conjugate quantities can be, for example, position and momentum, energy and time, and like that. Then these conjugate quantities, if we are trying to measure these conjugate quantities simultaneously, then there will be an uncertainty or small amount of inaccuracy in both these quantities. And if you take the product of these uncertainties, that will be having a value which is greater than or equal to h cut by 2, where h is Planck's constant and h cut is h by 2 pi. Or we can also put this statement like this: the product of uncertainties in any two conjugate quantities will be greater than or equal to h cut by 2, or it is impossible to measure simultaneously and accurately two conjugate quantities. For example, we can consider position and momentum, and we can also consider energy and time. That is, if you are, for example, if you are trying to measure position and momentum simultaneously, then there will be an inaccuracy in both the quantities, inaccuracy in measuring both the quantities. If you are trying to improve the accuracy of one quantity, if you are trying to improve the accuracy of position, inaccuracy in momentum will increase. And if you are trying to increase the accuracy in momentum, inaccuracy in position will increase. Anyway, if we take the product of these two inaccuracies in measuring position and momentum, the minimum value will be equal to h cut by 2. It can also be greater than h cut by 2. That is Heisenberg's uncertainty principle. The product of uncertainties in any two conjugate quantities will be greater than or equal to h cut by 2, or it is impossible to measure simultaneously and accurately two conjugate quantities. This mathematical statement for uncertainty principle is, for position and momentum, is delta x, delta p greater than or equal to h cut by 2, where delta x is the uncertainty in position, and delta p is the uncertainty in momentum, or you can take this as px, where px is the x component of momentum. The momentum is a vector, and in 3 dimensions it can have 3 components: px, py and pz. So in terms of x component, mathematical statement for Heisenberg's uncertainty relation is delta x, delta px greater than or equal to h cut by 2. We can write this in terms of y also: delta y, delta py greater than or equal to h cut by 2, or delta z, delta pz can be greater than or equal to h cut by 2. These are the mathematical statement for uncertainty in position and momentum. Then we have another pair of conjugate quantity, that is energy and time. The mathematical statement for uncertainty in energy and time is delta E, delta T greater than or equal to h cut by 2, where delta E is the uncertainty in energy and delta T is the uncertainty in time. Time and energy are two conjugate quantities, so it is not possible to measure simultaneously and accurately energy and time. If you are measuring energy and time simultaneously, there will be an error in both the quantities, and the product of the error will be greater than or equal to h cut by 2. Here, this energy, we know that energy of quantum photon will be equal to E into h nu, or then we can write delta E is equal to h into delta nu. So this can also be expressed as h delta nu delta T greater than or equal to h cut by 2. This is the mathematical representation or mathematical statement of Heisenberg's uncertainty principle.